Hello, welcome to Mr. Miles Maths. Today we have our first request for a video, which is on angles and parallel lines. So thank you, Eliza, for your request. We're going to run straight through this. There's three different types that we're going to look at: corresponding, alternate and interior angles. And then we'll talk a bit about vertically opposite as well. Then we'll have a look at some questions of increasing difficulty on this. So the first question, the first thing we're going to look at is just what the types of angles are and what they and how we can represent them and recognize them on our diagrams. So the first one is corresponding angles. So in corresponding angles, we have two angles that are said to be corresponding, are two angles like this. And corresponding angles are equal, so we can write that down at the side. So corresponding angles are equal. Okay, so they are the same. So to recognize corresponding angles, some people call these F angles. You don't get an exam for writing that down because it doesn't mean anything, it's just a way of remembering, because it kind of makes a letter F as you draw it out. These are known as kind of F angles, but you're better off learning them as corresponding angles if you can. So corresponding angles occur when you've got the two parallel lines and what we call the transversal, which is the line that goes across that. So this thing here is the transversal. It's just a fancy word for saying the line that crosses the parallel lines. The parallel lines are recognizable by the arrows, which indicate they are parallel. They will never meet. We've got to look out for those arrows here and here. Otherwise, none of the maths behind this works. So for example, if this angle here was 120 degrees, this one would also be 120 degrees because it is a corresponding angle to the one just above it. And there are a few corresponding angles in this diagram. So those ones will be corresponding to each other, but also these ones will be corresponding to each other. They're in the same place in relation to the point where the line that crosses them meets the two parallel lines respectively. So because that's the bottom left and bottom left, they will be corresponding angles. They will be equal. Okay, the same happens with the kind of top left angles from where they meet. So this angle would be the same as this angle. And then finally, the other kind of pair of corresponding angles that we'd have here would be this angle here being the same as this angle here. So if this was 70 degrees, for example, this would also be 70 degrees. So they're what we call corresponding angles because they correspond to the same point in relation to where the line meets the parallel lines. So both in the kind of top right in that case. And corresponding angles are equal, and we can use that fact readily if we know that they are parallel lines. The next one is alternate angles. And again, alternate angles are equal, so we can write that down at the side. So if we have this occurring where we have alternate angles, we know that they are also the same. Alternate angles are remembered as kind of Z angles. People remember them like that because they make a letter Z. Again, nothing in your exam if you write Z angles. You have to write alternate angles for it to be correct. So our alternate angles, I always like to think of this as alternating, means going back and forth. So alternate angles go on opposite sides and in between. So they're alternating sides of the line that crosses the parallel lines. So for example, if this was 70 degrees, this would also be 70 degrees, and the reason would be alternate angles. And there's another set of alternate angles on this diagram as well. So for example, if we had this angle here, let's say this was 110 degrees, this would be alternate because it's on the other side, still within the two parallel lines, but on the other side means that these angles are the same because they are what we call alternate angles. It might be a good idea to write these things down or pause the video, copy the diagram so you've drawn it yourself, so you know that they are alternate angles and you've practiced drawing it and therefore recognizing what happens. And the last one is allied angles. Sometimes these are referred to as co-interior angles, and these are slightly different in that allied angles or co-interior angles or even just interior angles. So allied angles add up to 180 degrees. And you kind of don't actually need this angle fact because you can use all the other ones above to do this. But say this angle here and this angle here, they would add up to 180. So if this was 70 degrees, this one would have to be 110 degrees. And the reason for that is that they are called allied angles or co-interior or just interior angles as well. But you can use corresponding, you can use alternate, any mixture of any of these angles, and you'll be able to get your correct answers through this. Okay, so if I said this was X and this was Y, then X plus Y would be 180 degrees. And don't worry too much about if the X and Y confuse you a little bit, don't worry too much. Wait for the examples and I can show you what happens. So they're the three different types. I will mention vertically opposite briefly. So vertically opposite angles or if I have two lines, any two lines that meet in space. Vertically opposite just means angles that are directly opposite each other. It doesn't have to be vertically, which is a bit weird because they're called vertically opposite, but this angle here would be the same as this angle. If this was 110, this would be 110 because they would be vertically opposite angles, and vertically opposite angles are equal. So I can make a little note of that as well. And also the ones, if I made this kind of blue instead, then this would also be vertically opposite to this, and these all lie on a straight line. So we're going to get 70 and 70. In this particular example, they're the same because they're vertically opposite. Any two angles that are completely opposite where lines meet are called vertically opposite, and they are the same. And then angles around a point add up to 360. Hopefully we're aware of that fact. So all these should also add up to 360. But let's look at some examples. So let's look at question 1 here. Let me just move this out of the way. So if I look at question 1, then we can get stuck into how these questions work. So there's a range of things going on here in this question. We can do lots of different ways of describing this. I'm just going to go for the way that I feel I would approach this question and try to explain how this works. So this first letter, I'm going to do it in alphabetical order. So A in this question would be equal to 62 degrees because this angle here to the top left of where the angle meets these parallel lines is corresponding to this angle. They're both kind of in the top left part of where the point is, where the lines intersect, where they meet. So if this one is 62 up here, then this one is 62. So this angle corresponds to this angle here. Okay, they kind of make that F, upside down F shape between them. So we'd write A equals 62, and they will ask for reasoning in exams. So you just put corresponding angles are equal. Okay, and then you've got the value, and you've also got the reason why that happens. So I can annotate my diagram. That might just help to add a little bit of information so that I can then start working out other angles around this. There is no B in this question for some reason, maybe because it looks a bit like a 6, but we'll look for C instead. So C, hopefully we can see that C, this angle in here, lies on a straight line with the 62. So these two angles on a straight line, we should know that they add up to 180 degrees. So I know that whatever C is, add that 62 is 180. So if I do 180 minus 62, then I'll get my value for C. And that's just angles on a straight line. So C will be 118 degrees, and the reason is angle sum. So sum just what they add up to, angle sum on a straight line. So this means C is 118, and it might help to add this in. And then this should unlock all the different parts of this question here. So now if I look at D, D in relation to where the points are is in the kind of top right, just like C is. So D will be equal to C, again, because they are corresponding angles. So D will be 118 degrees, and we could say corresponding angles are equal, and actually corresponds to C. So you could maybe make a little note of that. And then we can gradually build up the picture. E will be equal to 62. Two reasons: we can either use angles on a straight line. So we should be able to see this straight line here, that this will be 62 because it adds up with D. We could also use one of the angle facts above, because that 62 will be alternate to the 62 down here. Again, you can kind of see that Z angle that we mentioned before. So they are alternate angles, alternating sides of the line. One is on this side, the other side on the other corner will be the same. It will be 62 because they are alternate. So we can write that down. So E equals 62, alternate angles are equal, as our reason. Or you could write angles on a straight line, as it's the same with D. And then lastly, F will be 118. And again, two different reasons for this. Either we could have it vertically opposite to C, or we could say it's on a straight line with A, and angles on a straight line add up to 180. So I'm going to go here for vertically opposite angles are equal. And as if you annotate the diagram and show the information on the diagram, then that should also be considered and marked, and it will just help you. The more information you put in the diagram, the less you have to remember, and the easier it is to spot where things are. So that's just using one line, basic kind of rules in each case. Okay, so number 2. 2 is a little bit different, and we have 2 transversals this time. We've got 2 lines that cross. Remember, the transversal is just the line that crosses the 2 parallel lines. So this is one transversal and this is another. And with these kind of geometrical questions, quite often people find them more difficult. The more angles and lines you put on, the more confusing it becomes. We've got to try and make sure we break it down into which angles are which and which lines are which as well. So I'm going to concentrate on one line at a time. We need both the parallel lines acting in each question for this to work. So we're looking at how our transversal, that diagonal line, how that crosses the parallel lines, which is important. So I'm just going to kind of almost bin off this line, not worry about it too much for now. We'll concentrate on one at a time and try and distance the other line from everything else that you're looking at. So let's go in alphabetical order again. So this time A is on a straight line with a 98. So these will add up to 180. So A will just be 82 degrees. And this is the angle sum on a straight line as my reasoning. And again, I will annotate my diagram to show that. Remember, if it's a little bit quick, you can pause the video and you can just look through things or copy up the answers that I'm writing down if I'm going a little bit too fast, just to slow things down. So this will be 82. And then C, again, lots of different reasons, but C will be equal to 98 degrees. And again, we can have vertically opposite angles are equal. Again, write down our reasoning. So vertically opposite angles, again, if I've got 2 lines that meet, angles that are directly opposite each other like this are vertically opposite. And then we'll also have our E value and our D value. So we could say, again, lots of different reasons, but I'm going to go for D is 82 degrees because D is alternate to this angle up here, this A angle up here. So D is 82 degrees. We can say alternate angles are equal. You could use allied angles, but here alternate angles is absolutely fine. Oh, sorry, they're corresponding, aren't they? That should be corresponding. Just squeeze it in. So again, in relation to the point where the line meets the parallel line, they're both in kind of like the top right part. So that makes them corresponding. And then last but not least, E, again, we can use straight line geometry. They add up to 180. So these two must add up to 180 because they're on the same straight line here. Or we can use the fact that 98 will be corresponding to the 82. So either way, E is 98 degrees, and I'm going to go, this time, angle sum on a straight line. So that's A, C, D, and E. And then notice how the other line didn't really have any effect because it's got its own kind of life and its own little world on this side. And then I can go F. So F is on a straight line with 52. So if I do 180 minus 52, I'll get 128. So I can tag that in and say angle sum of straight line. So angle sum on a straight line. And then G, this angle here, will be alternate to this, again alternating sides of the line. So G will be the same as the 52. And we can say alternate angles are equal. So I can put in 52 here, and then that means H must also be 128 because it is on a straight line with G, which is 52. So this is angle sum on a straight line. So this will be 128, we said, didn't we? Yeah. And that's question 2 done. Again, if you want to pause the video and just kind of take stock, then please do, because I know I can be a bit quick and there's a lot of information, lots of reasons going down. Okay, last 2 questions. So 3 and 4. These questions are a little bit more complicated because they don't give you as much information and there's more lines to figure out what's going on. What I would say with these questions, don't always try and jump to where X is or D or E or whatever the letters you're trying to find. Use the information you've got just to discover new angles, and gradually as you do that, hopefully things will kind of piece together and that should start to unlock the values or the unknowns that you're asked to find. So don't always think, where's X? How can I find X directly? Think, what have they given me and how can I use that to help me? And that's what these two questions are all about. So two parallel lines indicated by the arrows here and here. And that means we've got two different transversals that make this triangle. So I've got this line here and then the other line here. What I would say is, as soon as I see these little lines, hopefully you know what they mean. They mean that this is an isosceles triangle, and that means those lengths are the same, and that means the angles opposite, so this angle here and this angle here, are equal to each other. So that might come into play. That's probably why they've told me that they are the same. We've only been given one angle, the 72, so we need to think, how can I use that 72? What can I do with it to help me? And I'm going to use the fact that they've given me parallel lines and this line here. So I therefore know that this angle in here is going to be 72 degrees because it is an alternate angle to that 72 there. Okay, and the reasoning is a little bit tricky here because we've not labelled that angle, but you could call it, say, X, and then say X equals 72 alternate angles. I could just label it here, and if you want to make a little reference, you could write alternate angles are equal here to make it nice and clear what you've done. And therefore, so E would be equal to 108, as it is then on angle sum of a straight line. Or we could use that interior angle, but I tend to avoid that. So this is angle sum on a straight line. So this is 72. Now we can use the fact that we've got equal length sides here. So the angles opposite that, so if I draw a triangle, which is isosceles, very loosely there, sorry, it's not my neatest ever creation. If I draw my triangle here with two lines here, the angles opposite that, so this one and this one, are equal. So that means in my diagram that this is 72 in here as well. So I'll just make that a little bit smaller. So if this is 72 degrees, this must be 72 degrees because this is an isosceles triangle, and therefore those angles are equal. And that means I can now find this top angle up here, because this top angle will be 180, take away those two 72s, which is 180 minus 144, which is just 36 degrees. And again, I can annotate that. And this is angle sum of a triangle. So that'll be my reasoning. And then hopefully you can see that D therefore is 180 minus the 72 and minus the 36, or 180 minus 108. So we're going to get 72 degrees for D in here as well. So notice how I didn't really think about D at all. Once I found my alternate angle of 72, I then realized I could find E. I used my isosceles triangle fact to find the other angle. Then I think, I've got two angles in a triangle. I may as well find the third. It's going to be useful to do that. And then once you've got that, angles on a straight line, and that leads you into this question. And then the last one we're going to look at, sometimes it might help to extend lines a little bit so you can see what's going on. So I'm just going to do that very briefly, just to make it a little bit clearer where my transversals are and where my parallel line is. And again, I'm thinking, G's a little bit funny here. I don't want to dive in too much. But as soon as I see these, why have they bothered to tell me this? They've given you that information. There must be a reason for it. And again, this is an isosceles triangle. So that means this must be 59 degrees because of an isosceles triangle. And then again, I've got two angles in the triangle, so I can definitely find this top one. So that top one will be 180 minus that 59 and the other 59 in the triangle, or 180 minus 118, which is 62 degrees. So this must be 62. And then I might think, how can I find my G? And hopefully, again, you might want to pause it because I'm just going to give you the answer straight away, just to see if you can spot it. So now would be a good time to pause. Otherwise, we're looking at this situation. We've got a transversal, and now we can use the fact that they've given us parallel lines. So G must be 62 degrees in here because G is alternate to the 62 in the top of the triangle, and alternate angles are equal. So again, hopefully that's a good way of looking at the question rather than trying to find where's G, how do I find it, what can I do with the 59 they've given me? That's the only information I've got. Why have they given me the little marks? Well, I suppose that's the second bit of information they've given you. And then you can find the other angle. That means you can find the third angle. And even if you didn't quite spot the alternate angles, you're going to get marks for building together an argument. And then why have they given me parallel lines and this line that crosses them? I can see these alternate angles here. Hopefully that's been useful. If you've got requests, please keep them coming. It's good to do something that's actually been asked for by someone who's watched some of the other videos that I've done. And if you like the videos, then please like. And if you like all the other videos, there's always new ones coming out at the moment, then please subscribe. Thank you. See ya.